Hello friends, welcome back to the second lecture on non-parametric methods in data analysis. In the first lecture we discussed about the conditions for which we have to go for the non-parametric methods, and in this video we will discuss the first non-parametric methods that we have in our list, which is one sample sign test, right? So now one sample sign test is the non-parametric counterpart of t-test, right? So as I have already explained in the previous video, now you can read these things in order to understand the theory. After that we will perform or we will attempt 4 questions, right? So I will demonstrate how you can perform these questions manually and using Minitab software, right? So as you can see here, the one sample sign test is a non-parametric test used to determine if the median, right? So now this is also a very important point. Here we will compare the median, right? So in our parametric methods we compared mean, but here we will compare median, and we will denote median using the Greek letter eta, right? Okay. Of a single sample differs from a specified value. This test is especially useful when the data are not normally distributed, right? So that's what we have already discussed in our previous lecture also. When the sample size is small, right? So even when the sample size is small, or if the data set is not normally distributed, we will go for the non-parametric test. Now the first step is to state the hypothesis. Now we have the null hypothesis. So this is how we have to write down the null hypothesis. The median of the population is equal to the specified value. In the question they will give the climb, right? So the climb is the specified value, right? So the value in our climb. For example, if you look at the first one, a science college lecturer claims that the median exam marks for his student in the last term is 65. So this 65 is the specified value mentioned here. Okay, right? So now this is the null hypothesis. So you can say that eta. So you can say eta is equal to specified value. So this will be our H naught. Now HA, alternative hypothesis may be eta is not equal to specified value. So in this scenario we will take two-tailed test, and sometimes it may be eta less than specified value. So in this scenario, and eta greater than specified value, we will take our one tail test, and this will be left tail and this will be right tail, right? So this is what we have studied under hypothesis testing. So when we attempt the questions, first we will write down the corresponding hypothesis and then test for the hypothesis testing. Okay, right? Now H1, or alternative hypothesis, the median of the population is not equal to the specified value, right? So in that scenario, as I told you, we will take the two-tailed test and is greater or less than, right? So here in this scenario we will take our one-tailed test. Now these are the steps that we have to follow in order to perform this one sample sign test. First we have to state the claim of this test and determine the null hypothesis and alternative hypothesis. After that we have to specify the level of significance. We have to specify the significance level alpha. So typically we take 0.05, right? Determine the sample size n by assigning positive and negative signs to the sample data. Now here what we will take is we will compare the actual data point with the specified value, right? So if our actual data is greater than the specified value, we will assign positive sign corresponding to the data. In contrast, if our actual data is less than our specified value, we will assign a negative sign. And if our actual data, or if our actual data point, right? So I am just talking about the individual points. if our actual data point is equal to specified value, so we will assign 0. So we will just ignore this 0, we will ignore, and ultimately in order to find the sample size we will just add this plus number of plus signs and number of negative signs. So when we perform this hypothesis testing, in order to find the test statistic, we will consider n is equal to number of positive signs plus number of negative signs. For example, if we have 12 observations and after comparing the actual data with the specified value in the claim, if we have 2 zeros, now our sample size n will become 10, right? Because we have to ignore these values having assigned 0 value, right? So if the data point is assigned 0, then we will just ignore. So if we have 12 observation, actually we have 12 observation, but 2 observations got 0, so right? So these 2 observations got 0. In that scenario, our sample size now will become n is equal to 10, because we have ignored these 2 data values that have been assigned 0. Okay, right. Now find the critical value, right? So in order to find the critical value we have to go for the table. So the table will appear like this, right? From this table we have to find out the critical value. So if it is a two-tailed test, we can get the value below this one, and if it is a one-tailed test, we have to see below this, right? And these are the alpha values. So for example, if it is a two-tailed test and if the significance level is 0.05, we will look under this column, right? And depending on the sample size, we will get the corresponding value like that, right? So when we do questions, you can easily understand that. Okay, so now from the table we can find the critical value. So this critical value is obtained from the table. Now we have to find out the test statistic, right? So now we have to find the critical value from the table. You can understand the differences between the words that we use here. And we have to compute the test statistic, right? So compute means we have to calculate the test statistic, right? So we have to calculate the test statistics, right? So when n is less than or equal to 25, when n is equal to less than or equal to 25, the x test statistic we will assign the name, right? So if now test statistic, right? So if our sample size is less than or equal to 25, our test statistic will be x. Now x is equal to minimum of number of positive signs comma number of negative signs, right? For example, if our number of positive sign is 6 and if our number of negative signs is 2, so x will take the value 2, right? Because that is the minimum of these two values. And if our n is greater than 25, now we have an equation for this. So now we will assign the letter z for this test statistic. So this will be equal to x plus 0.5 minus 0.5 n divided by 0.5 n, right? So here the n that we have in this equation is the number of the summation of number of positive sign and negative signs, right? So even though if we have originally 12 observations, after finding out the n as 10, you have to substitute this n here. Okay. At the same time, our x, this x is the number of smallest number of negative or positive signs. So for example, here you can see where x is the smaller number of positive and negative signs, which means here in this case we have to put n is equal to 8, right? So if I consider the number of positive signs as 6 and if the number of positive signs is 2, now here n is equal to 8. Why? Because 6 plus 2, but our x will be this 2, so this is our x. I hope you can understand this, right? So in the equation we have two unknown values, x. So x is the smallest number of positive or negative signs, and n is the sample size. So sample size, now we just ignore our zeros, so that will be the summation of positive signs and negative signs, right? For example, here in this case, the n, right, the sample size is 8, that is the summation or addition of number of positive signs and number of negative signs, and here x will be the lowest number, right? So here among the two, what is the lowest number? We will put that here, right? Now again, after finding the test statistic, we have to conclude, right? So make decision, we have to make decision. The null hypothesis will be rejected if the test statistics is less than or equal to critical value, right? Okay, so here there is a contradiction with our parametric methods. So in our parametric method, right, so let me write like this. So let's say in our parametric methods, if the test statistic, if our test statistic is greater than the critical value obtained from the table, we will reject H naught. But in non-parametric test, the vice versa. If the test statistic is less than critical value, so in this scenario we will reject H naught, right? So we will reject H naught, right? So this is what you have to remember. Sometimes in the examination you might confuse, right? So far we have rejected the H naught if the test statistic is greater than the critical value. But when we are performing non-parametric methods, if the test statistic is less than the critical value, we have to reject H naught, right? Okay. Now we will come to the first example that we have here. So here a science college lecturer is claimed that the median exam mark for his student in the last term is 65. The marks for 12 randomly selected exams are listed below. At 5% significance level, can you reject the lecturer's claim? Okay, so first we have to understand this question. We have been given a one sample, one sample, right? So we have been given a single sample, and the lecturer's claim is, he says the median marks of his class is 65, right? So this is our claim, right? So this is actually our H naught. Then we can say that H1, or okay, now I'm writing over here. Okay, let me create some space. Okay, so they are telling, it is said that our lecturer says eta is equal to 65. This is our claim and it will be our null hypothesis. So H1 is equal to, H1 will be eta is not equal to 65. There is no story like greater than or equal, right? So this will be a two-tailed test. Okay, this will be a two-tailed test. So here the number of observations n is equal to 20. This is the original sample size, but we have to assign the signs for each data points considering the each data values with the specified value in our claim, right? So now if our actual data point is greater than 65, we will assign positive sign. If it is less than 65, we will assign negative sign. If they are equal, we will assign 0, right? Now in this case, here 69 greater than 65, so plus minus plus minus, plus, 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 plus. Okay, now we will count the number of positive signs and the number of negative signs. So the number of positive signs is 1, 2, 3, 4, 5, 6, 7, 8, right? So 8, and the number of negative signs is 4, right? Now here you can see the output, Minitab output is given here. So from the P, now we will check if we also can get the value P is equal to 0.3877. Right. So now the theory for P value is common for both parametric and non-parametric methods, right? So if our P value is less than our alpha value, we will reject H naught, right? So this is common for both our parametric and non-parametric methods. So here you can see P is greater than, right? So if P is greater than alpha value, so since our P value is greater than alpha value, we cannot reject H naught for this question. So what can we conclude? If we cannot reject our H naught, we have to accept that. So the lecturer's claim is correct. This is what we will statistically conclude. Now we will try to get our P value using our Minitab software. After that I will explain how you can do this comparing our test statistic and critical value, right? Okay. So I have already entered the values for this one. You can see here marks. So under marks column I have entered everything. Now this is the procedure you have to follow. Go to stat non-parametric one sample sign test, and the variable that I have to consider is marks. Okay, and confidence interval, I don't want to worry about this confidence interval. By default it is enabled, it is disabled, right? So and it's appearing 695, and my test median is according to the question 65, right? So 65, and if you can see here our so this is equal, right? So alternative hypothesis is not equal, so we have to select not equal, right? So we have three options for alternative: less than, not equal, greater than. For this question, since I have not equal, so I have to select not equal. Okay, so you can see here I'm sorry. Okay, I made a mistake here, right? So now, okay, so let me just change some data. Yeah, okay, so I have to just change this data as 64, right? Okay, 64, then only will give the correctly 64, right? So okay, now in the question the fifth data is 64, but initially I typed 65 because I wanted to show you what will happen if we have a data point that is equal to our specified value as well, right? So 64 enter. So now I will calculate this statistic, non-parametric methods, sign, mark 65. Okay, so now you can see here our P value is, let me insert, this picture to our OneNote application so that I can annotate and explain. Okay, so as you can see here, now this is the sign test for median, right? So sign test for median, right? So basically sign test for conducted for median, not for mean, and the data point that we have taken is marks. Now eta represents the median of marks, right? So this is our actual median of the data points that we have, that is 68.5. Now our null hypothesis is given here, n is equal to 65 and eta is not equal to 65, right? So now here we have number of negative signs for number less than 65, number equal to 65 0, number greater than 65 8, and the p-value for this test is 0.388, right? So since our p-value is greater than our alpha value, we cannot reject h naught, right? So we cannot reject h naught, so we can statistically conclude that there is enough evidence to support lecturer's claim. So the median marks of his class is 65, even though the actual marks is 68.5. At 95 confidence level, we can conclude that the lecturer's claim is okay, correct, okay, right? So now we will see how we can conclude or come to a decision whether to reject h naught or not using our test statistic and critical value. Okay, so now you can see our test statistics. Now first let's compare. If our n is equal to 10, this is absolutely less than 25, right? So less than or equal to 25. So we have to take the x is equal to minimum of number of positive signs and number of negative signs. So here minimum of 8,4, so 4 is our test statistic, right? Now we have to compare our critical value. So critical value can be obtained from our table. So now we will go to the table to find out this critical value. So we have two-tailed, right? Two-tailed test, and our alpha value is 0.05 and our sample size is 10. So the corresponding critical value is 1. Okay. So here critical value is 1. Oh, I'm sorry. Okay, so this is n is not equal to 10, n is equal to 12, right? I'm sorry. N is equal to 12. So our critical value will be 12. So that will be 2, right? So I'm sorry, because okay, right. So our n is 12. So our critical value is 2 along the alpha value in two-tailed test. So here our critical value is 2. Now we have to consider if our, now since 4, right, that is our test statistics is greater than the critical value, right? So since our test statistic is greater than our critical value, we cannot reject h naught. This is actually contradiction to our parametric methods, right? So we cannot reject h naught. So we can conclude that we have to accept it, right? So the lecturer's claim is okay. This is how we have to do it, right? Okay. Now I will explain you how you can obtain this p-value, right? So using our binomial test. Okay. Right, so you can see here we have two outcomes, positive and negative, right? So we are not going to bother about our 0. Before that, before we come to this binomial test, let me explain what will happen if we change the fifth data point to 65, right? So as I already did, so now I'm just going to change this 64 as 65, So if I change the 65, now I change 64 as 65, so one negative signs will reduce and it will become 0. So now we will have 0 1, our positive signs will be not change, there will be no change in our positive number of positive signs, that will be 8. Now our negative signs, number of negative signs will reduce by 1, right? So now here I will calculate stat non-parametric test, one sample sign test, marks, okay, everything is okay. Right, now you can see here the p-value has changed to 0.227, right? So the similar way you can conclude that again the lecturer's claim is okay. The lecturer's claim is okay. Now we will see how we can obtain this p-value of 0.38, something like that, right? Okay, and this p-value 0.227, okay, using our binomial test. So let me insert this also. Right, so this is for the modified data where we changed our fifth data point to 65. Okay, right. Now let's try to understand. Here you can see this is the sign test for median. The variable the data set is marks. Okay, so eta represents the median of marks, and the total number of observation that we had is 12, and the actual median 68.5. okay, right. So the median will not change even though we change the data, the median has not changed, right? So null hypothesis is 65. This is okay. Now you can see this is assigned 0, and the number of negative signs is equal to 3, and there is no change in our number of positive signs. And the p-value also p-value also has changed to 0.227. Earlier it was 0.388. Okay, so now we will see how we can find out the probability value using manual calculation, right? So let me create some space here. Right, okay, so here you can see we have two outcomes, right? So the first outcome is positive and the other outcome is negative. So number of positive outcome is 8 and the negative outcome is 4, right? And our claim that we know median is equal to 65. Okay, now it follows to a binomial distribution x, right? So x is our success. X follows to binomial distribution with n comma p, right? So n is the number of trials and p is the probability of success. Now we have to brush up our knowledge in binomial distribution. If in binomial distribution, if p, x is a random variable, x is our expected outcomes, is equal to ncx px q n minus x, right? So this is the probability mass function for binomial distribution. Now if we want to, now what we have to find out is our success. We have to first define, or first we have to identify our success. What is our success? So according to our claim, right? So here we can take anything as success. So I am going to take the success as getting positive signs, right? So our success is positive signs. So I will take probability of x greater than or equal to 8, right? So this is our success probability, that will be equal to 1 minus probability of x less than or equal to 7, right? So one number less than 8, right? So okay, right? So here you can see probability of x greater than or equal to 8 mean we have to add the individual probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10 plus probability of x is equal to 11 and plus probability of x is equal to 12, right? So this all we have to add all these. Otherwise what we can do is, before that we have probability of x is equal to 0 to probability of x is equal to 8, right? So the total probability is equal to 1 minus probability of x is equal to 0 plus probability of x is equal to 1 up to probability of plus probability of x is equal to 7. This is what we have to find out. Okay, right. Now I will tell you how you can use your calculator for finding out this one, right? So we know that this is okay, right? So this can be now written as 1 minus summation x is equal to 0 to 7 probability of x is equal to x. I can write this way. Yeah. Okay. So now 1 minus this, right? So I have to find out this value using my calculator, right? So here let me just copy this. And go to the calculator. So I have just inserted the image of the calculator that I'm going to use. You can work along with me. Oh. Right. Now what I have to find out is this value, right? So how can we feed the data, or how can we manipulate this calculator to obtain this value when n is equal to 10 and our probability value typically we take 0.5 if there is no information about our success probability, right? So now you can see probability of x is equal to NCX probability of x px q n minus x, right? So now what I have to do is I have to feed this data, right? So you can do along with me. So first we have to on, right? So you have to press on button. After that you have to add this, right? Summation, right? So summation can be displayed by pressing the log symbol, right? So this one you can see here, log. Above that we have summation in yellow color. So you are supposed to press this button along with shift. Okay, so shift plus this, right? So it will give you summation. After that now within the expression, now this is how your display will appear. Summation x is equal to box, and here also box and bracket. Now the cursor is here. Now you have to type everything coming here, right? So now 12 cx, right, x. So x can take any values from 0 to 7, right? So we have to add all of them. Probability 0.5 x and 0.5 12 minus x, right? So this is what we have to type. So first you can type 1 2, we can press 1 2, then we have to press combination, right? Combination. So combination, so you can see here right here NCR with division symbol, right? But here we have in yellow color, so we are supposed to press this division button using along with the shift button, right? So shift plus this, right? Shift C and then x, right? So now if you want to press x here you can see x is here, but it is in purple color, so you are supposed to press it with along with this button, right? So this alpha button, so alpha x, right? So alpha x, you have to press this. Okay, after that multiplication symbol, this one, right? So if you don't know how to find the binomial, cumulative binomial probability values using calculator, this may be helpful for you, right? So you can work along with me. Now here 0.5 power, right? So 0.5 power this button power. Now we have to put x here again, right? So again, if you want to type x here, alpha and close bracket, right? Alpha close bracket, and again you have to press this to bring the cursor to the primary line, right? Okay, again multiplication symbol, this one, and then we have to press again 0.5 power n minus x, so that is 12 minus x, right? So after pressing 0.5, then press this one in order to write the, in order to type the exponent. So now 12 1 comma 2, this button and this button, minus this button, 12 minus, and x again alpha and close bracket, right? So alpha x. Okay, and ultimately we have to type this also, right? So the starting point and the ending point of these terms in the series. So that is again you have to bring the cursor here, right? So if you press this again, it will bring here, the cursor will come here. So here we have to type 0, and again if you press this, it will, the cursor will come here. So here 7. Now if you press equal sign, it will give you the value for this. So that is equal to 0.8061, right? So 0.8061. So now I will go to our lecture module. Here this is equal to 0.8061. 1 minus 0.8061, that is equal to 0.1938, right? So this is one tail. This is the probability of one tail. If you consider this has given this probability only one tail, but I need two tail probability, right? So here if you want the probability for the two tail probability, I have to multiply this by 2, right? So this will give you this value, actually this value 0.388, approximately 0.388. So this is how we have to find out the probability using manual calculation, but in examination it is not required. If it is a practical exam, we can follow the method that I explained using Minitab software, and if you want to write in the theoretical examination, it is sufficient for coming to the conclusion using our test statistic and critical value. Anyhow, this may be an additional knowledge for you. Now we will see how we can find out the value for this p value, right? So this p value again you can use the same method, but I will not explain everything here, right? So I will just explain how you can find this, but using the same method I explained, you can do that in order to find the probability of this one also, right? So here you can see we will ignore this one, right? So now our n is equal to 11, we will consider x is equal to our, okay, so we need our probability, right? So here also if you change it, you can again conclude that if the p value is greater than alpha value, we cannot reject h naught, right? We cannot reject h naught. Still the lecturer's claim is okay. And here you can see since okay, now we will see how we can conclude or we can come to the conclusion using our test statistic and critical value. Our test statistic is equal to this, x is equal to 3, and our critical value from the table, now this is a two-tailed test and 0.05, but our n is equal to 11, right? So n is equal to 11. Let me go to the table. So this is a two-tailed test and alpha is 0.05, but our sample size is 11, so 1, right? So critical value is equal to 1. So since my test value is greater than our test statistic value is greater than critical value, we cannot reject H naught, right? So we cannot reject H naught. So the lecturer's claim is correct. Okay, right. Now if you want to find out this p value, now probability, what we are interested in is probability of x greater than or equal to 8, because we are going to consider the success as probability of getting the positive sign as probability of success, right? So probability of x greater than or equal to 8. So this is again 1 minus probability of x less than or equal to 7. So 1 minus probability of x is equal to 0 plus probability of x is equal to 1 until probability of x is equal to 7, right? So now this is equal to 1 minus summation of x is equal to 0 to 7, now 11, right? So now instead of n I have to put 11 c x, right? Because x can take all the values from 0 to 7. P, now again 0.5 x, 0.5 11 minus x is equal to, right? So okay, let's calculate, right? So you also can pause the video and calculate. I also will try now. Oh, I pressed alt cut, otherwise I would have changed the values in the existing expression. Anyways, summation 11 c x times 0.5 x d into again into 0.5 into the power 11 minus x. Now here this is 0 and this is 7, yeah. So this gives me the value of 1 minus this is equal to 0.8867 minus 1 is equal to 0.011328, right? So this is one tail, right? So this is the probability of one tail, but we need two tail, right? So we have to multiply this probability by 2, so it will give me 0.2265. so 0.2265, so this is approximately equal to 0.227 that we already obtained here, right? Okay, right. So I hope you have understood the first question. Now we will move to our second question. Right. So our second question says, a bank manager claims that the median number of customers per day is no more than 750. So if the claim is like this, So here they are telling the customers claim, they are telling no more than 750 means median, right? So no more than means it may be 750 and less than that, right? So median is less than or equal to 750. So since we have equal sign here, this will be our H naught, and our alternative hypothesis will be equal to median greater than 750, right? Okay, right. So a teller doubts that accuracy of this climb, right? So what is that? A teller doubts the accuracy of this climb, right? Now we have to perform hypothesis testing. The number of bank customers per day for 16 randomly selected, right? So we have the number of customers arriving to the bank in 16 days, right? So day is equal to 16. But here you can see what is this 775, what is this 765. These are the number of customers coming to the bank daily or every day, right? So we have taken the data for 16 days. At 5% significant level of significance, can the teller reject the, okay, so this is what we have to do, right? Okay. Now here you can see the specified value is 760, right? So we will assign the positive and negative signs comparing each and every data point with 750, right? Okay, right. So 750 means plus, 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 minus, plus, plus, minus, plus, 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 0, minus. Okay, right. Now number of plus is equal to and number of negative is equal to, right? So here you can see number of plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And number of negative sign 1, 2, 3, so altogether 15, and 1 is 0. So now from this we can tell n is equal to 15. Okay, now let's see how we can do this using our Minitab software, right? So our Minitab software, I have already entered the data for customers under the C2, right? So under the, so C2 columns is the number of customers visiting the bank in 16 days. Okay, right. Now I will go to stat non-parametric one sample sign test for customers, and 750 is our test median, and our alternative is greater than, right? Because in the, you can see here in our alternative hypothesis we have mentioned, where is that? Oh, did I write? Oh, did I erase this? Okay, so now, okay, so in our H node we wrote mu eta is less than or equal to 750, no more than 750 customers, and eta greater than 750 was our HA, alternative hypothesis. Yeah, okay. So now we will go to our Minitab software, ribbon custom, oh, not this one, right? I have to test one sample sign for customers only, and 750, and this is greater than, yeah, right? So greater than, okay, right. So here you can see our p value is 0.018. Let me insert this into the, okay, I will just insert that picture into this one node. so that I can easily explain. Right, so you can see here right, so this is the sign test for median. The data set is customers and eta represents the median of customers, our descriptive statistics, right? So the total number of observation that we originally had is 16. You can see, I don't know if you can see my mouse, 16, and here the actual median is 758, right? So since our p-value is less than 0.05, so we will reject H0. We will reject H0. Right? So if we reject our H0, we will reject H0. So we will accept our alternative hypothesis. Definitely, so we can conclude that at 95% confidence level, the median should be greater than 750, right? So actually, what the teller doubted was okay, because the bank manager's claim was false here, right? So here you can see bank manager's claim was false and the teller's doubt is confirmed, right? Now here the teller has won the match, right? Okay. Yeah. Okay. So actually, yeah, definitely, because it is greater than 758. That's why he doubted, and the bank manager was proven to be false regarding this claim. Okay. Right. Now we will see how we can again find this probability value. So here you can see our p-value is 0.018, right? So now you can see our right. So you can see here our alternative hypothesis eta greater than 750. So our success is the number of, okay, so getting positive sign, right? Because then only it will be because the actual median is 758. Now if it is greater than 750, that is our success. So number of getting positive sign is 12, right? So now we need the probability of success, that is x greater than or equal to 12. So that can be written as 1 minus probability of x less than or equal to 11, right? Okay. So 1 minus, here n is equal to 15. Why? Because we are going to omit this data point. So already originally we had 16, but minus 1 only 15, right? So the summation of number of positive signs and the number of negative signs, right? So probability of right? So I can write this as summation of x is equal to 0 to 11 15 cx 0.5x into 0.5 15 minus x. So this is equal to you can calculate along with me summation 15 c x x into 0.5 power x into 0.5 power 15 minus x 0 to 11 is equal to it takes time, yeah, 0.982, right? So minus 1 is equal to 0.175. So 0.0175 mean 0.018 approximately, right? So we have obtained this p value because here in the previous case I multiplied by 2 because the original, okay, now here I multiplied by 2. Where here I multiplied by 2 because this probability value is for only one tail, and if you want to find out the probability of the two tail I have to multiply by 2, but here I am just considering only one tail, right? So here I don't want to multiply by 2 because our alternative hypothesis is greater than, right? So we have already considered our number of success, but here that is our alternative hypothesis was equal, not equal, right? So it was two tails, so I just wanted to multiply by 2, right? Now moving to the next question. That is our where is the third question? Some portion of the third question has been hidden by the page of the second question. How can I bring it down? Right. Okay. Now let's discuss our third question. Right. So the following are the measurements of breaking strength of certain kind of 2-inch cotton ribbon in pounds. Use the sign test to test the null hypothesis. Mu is equal to 160 against the hypothesis mu greater than 160, right? So they have given, even though we perform median analysis, they have given the mean anyhow. So mu is equal to 160 is our H naught, and HA is equal to mu greater than 160. So this is a right one tail test, right? Okay. At 5% significant level. Now here 160, right? So plus 0 plus minus plus 160. Let me 160 plus 0, 160 plus minus plus 160 mean here minus, yeah, don't confuse, minus plus here also plus minus minus plus. Okay, so the number of plus, number of minus is equal to. Let's count them. 1 2 3 4 5 6 7 8 9 10 11, 12, 13, 14, 15. 15. A number of negative. Here we have only one, right? So 1, 2, 3, 4. So 20, 19, 20. Okay. 20, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. So number of positive signs 15, number of negative signs 14. So here x is equal to 4 and our critical value is equal to so we can find using our table. So this is our critical value. Since this is our HA, so it is HA. So this is our one tail test and significant level is 0.05 and n is 19. Why? Because 19 n, our n is 19 because we will just ignore our 0, right? So this point, data point is ignored. Okay, so our actual, the modified sample size is 19. Here 5. But here if you consider this 20 also, no worries. But here if you have 16 data points, if after modification if you get 15, if you ignore the data values assigned 0, then it will be a problem, right? Okay, so here 5, critical value is 5, right? So since our x is less than critical value, we will reject h naught. We will reject our h naught. So if we reject our h naught, we will claim that the mean is greater than 160. Now we will perform this using our Minitef software. So I have the data here, ribbon, yeah. Right. So go to stat non-parametric test, one sample. Oh, stat non-parametric, one sample sign. So I have to consider the ribbon variable and the test median is 160. They have actually given the median as mean, right? Mu. Okay, that's not an issue. And our alternative hypothesis was greater than, right? So greater than, okay. So p value is 0.01. So since our p value is less than our alpha value, we cannot reject our h naught. So sorry, we will reject our h naught, right? Because this is less than alpha value. So let me insert this here. Right. So you can see this is the sign test for ribbon. Our median is ribbon, sample ribbon and 20 median. Now here you can see 4 is negative, 15 is positive. This is assigned for 0. So p value is 0.01. Now let's find this p value using our binomial test, right? So now I have to find our success is number of positive. So I need the probability of x greater than or equal to 15. That will be equal to 1 minus probability of x less than or equal to 14. So 1 minus our n is equal to now 19 and yeah, so we will calculate it. Shift this 19 c x times 0.5 power x times 0.5 power n minus x, that is 19 minus x, and here we have to add from 0 to 40. So this gives me let me wait. Okay, 0.099, right? So that is equal to 0.01 approximately. So we have found out this one also. Now we will move to our fourth question. Our fourth question. A fourth question says a car dealership claims to give customers a median trade or in offer of at least this. A random sample of 105 transactions revealed that the trade-in offer of 60 automobiles was less than $9,000, right? So first we have to understand this question. Let me erase all the annotations so that we can conveniently understand the question. Okay, so try to understand. Here the car dealership claims to give customers the median trade is equal to this, right? So our H naught eta is equal to $9,000. So HA eta is not equal to 9,000. So this is a two-tail test, right? Two-tail test. Now they are telling 105 samples, right? So n is equal to 105. They took 105 cars, but the automobile, only 60 automobile was less than the specified value. So negative, number of negative signs, right? So negative signs is equal to 60, and number of positive signs they have given and the trade in offer for 40 automobiles was more than 60,000, right? So you see here, trade in offer of 40 automobiles was more than $9,000. So it is above that. So if you subtract, so you will get positive. So number of positive signs 40, right? So if you add all together, now n is equal to 100. So 5 automobile or 5 cars were assigned 0 because their trade-in offer was exactly $9,000. Okay. So now we have to find out our x, that is the minimum of these two, that is 40, and now our n is greater than 25, right? So we cannot go for the table. Now we have to find out the test statistic, that is z, that is equal to x plus 0.5 minus 0. What is the value? This one, 0.5n, 0.5n divided by 0.5 square root of n, if I am not wrong. Yeah, okay. So here x is the minimum number of positive or negative signs, right? So x is equal to 40 plus 0.5 minus 0.5. Do we have n here? Yeah, n also there. So n is 100, right? So n here is 100 into 100. I already told you this is the summation of number of positive and negative signs divided by 0.5 square root of 100. So if you simplify it, 40.5 minus 50 is equal to divided by 0.5 square root of 100 minus 1.9, yeah, minus 1.9. So our z statistic is minus 1.9. So why we are performing z statistic is, so if you have a large number of data, right? So if the n is greater than 25, this is actually not non-parametric method. This is a parametric test, right? So now we have calculated the z statistic. Now we have to compare, right? So you can see here the alpha value is equal to 0.01. So if the alpha value is 0.01, we have to find out our critical value using our normal distribution table. Right. So if you look for the value, the probability, the critical value in 0.01 in z statistic, it gives minus 0.01 minus 2.33. okay, right. So here you can see, if you take the absolute values, here 1.9 is greater than, I'm sorry, 1.9 here, yeah. So this is our mod of z is equal to 1.9 is less than our z value, right? Z value. So here we cannot reject h naught, right? We cannot reject h naught. So if we cannot reject h naught, we will accept it. So we can tell that the median of this trade-in of these automobiles is $9,000. okay, so hope you have understood this question also. So in this lecture video, we just delve into this one sample sign test, and we have discussed 4 questions manually and using our Minitab software. So in the next lecture, we will be discussing our next topic, that is our one sample pair test. Okay, right. So if you found this video useful, please share it to your friends and subscribe to my YouTube channel. Bye.